first video in the series for Joyful Lessons in Heat Transfer. It's an introductory and basic video which will let you notified about the concepts of conduction, convection and radiation. The first comes conduction. It happens in solid, liquid and gases, and due to the mutual vibration and heat transfer between the molecules. Next is convection. This can occur natural, forced, boiling, condensation. We will discuss these in details in convection modules. Next is radiation, which can occur through any surface at a particular temperature. It doesn't require any medium for transfer, the most common being solar, visible, ultraviolet, infrared radiations. Now it's time to look at the building blocks of these three. The operating principle of conduction is Fourier's law, which has the basic equation Q double dash is equal to minus K dt by dx. Conduction occurs through material, so we can watch a temperature distribution which can be written as Tx is equal to T1 plus T2 minus T1 into x, which is the distance, divided by L. The temperature gradient developed is used in the Fourier's equation. Now in this equation, the letter K represents thermal conductivity, which has different values for different materials. Like metals have the highest thermal conductivity, so they have higher values, and gases have very low values. Heat flux is Q double dash. It's the heat passing perpendicular to an area. Here in the video we can see that for different configurations of area there is same heat passing through, and consequently they share the same heat flux. Heat rate is heat flux into area, and this is the normal area. It has the units watts or joule per second. Now comes convection. In this, Newton's law of cooling is the governing principle. For example, in a hot body undergoing convection, we can take Th as the surface temperature and the surrounding to be T infinity. Let x be the distance away from the surface. Then we get the temperature difference like this. Its equation comes to be Q double dash is equal to H into Th minus T infinity. In this, H is the convection coefficient, which is a value dependent upon several factors. We will investigate this in further lessons. Heat flux, cross-sectional area and heat rate follow the same rules as conduction. In radiation, Stefan-Boltzmann law works. As told before, it works like electromagnetic waves. It holds the equation Q double dash is equal to sigma E into T to the fourth power. In this, the value of sigma is the Stefan-Boltzmann constant, which is equal to 5.67 into 10 to the power minus 8 watt per meter square per Kelvin to the fourth power. Here E is the emissivity, which has values varying between 0 to 1. 1 can approach to a black body and 0 might be approached by reflective surfaces like snow, aluminium, etc., which do not absorb any heat. Heat flux, heat rate have the same principles as ever before.